Hi there, this is GCSE Physics. This is Particle Model Lesson 2, and this is Density Lesson 1. So the objectives are to describe what density is, to recall and apply the density equation, and to solve the MAD extension question. It is a very difficult question. You have to be very good mathematically to be able to do it. Alright, let's make a start. So density. Density is a measure of how compact a substance is, or how much mass it has according to its volume, or mass per unit volume. So here's some examples. So density is measured in kilograms per cubic meter. So it's how much mass there is in a cubic meter, 1 by 1 by 1 meter. So as you can see, there's big differences. Interstellar medium, that's space. So you're looking at 10 to the minus 25. So that's 0, 0, 0, loads of zeros, 0.1. So nothing at all. Then you got hydrogen, helium, air. So where's, just over a kilogram per cubic meter. Wood on average might be 700. Lots of different values. Gold, 19,300 kilograms for a cubic meter. The sun's core, if it were possible to get, a cubic meter of sun's core in front of you, that'd be 150,000 kilograms. Neutron star, 10 to the power of 17. Black hole greater than 4 times 10 to the power of 17 kilograms for every cubic meter. So vast differences in different materials. So there's an equation, mass is density times volume, or M equals rho V. That's not a P, it's rho, it's a Greek letter. When I manipulate the equation, show you how to use it, I'll show you what it looks like, a little bit more detail. So if you want to write this down, get some units down. So mass is measured in kilograms or grams. Density is measured in kilograms per cubic meter or grams per cubic meter. Grams per centimetre cube, sorry. And volumes either in meters cubed or centimeters cubed. It will be apparent which units you have to use when you do the questions. Alright, so let's look at some questions now. So the equation, mass is equal to density. So it's kind of like a P that's been like knocked over a little bit. Rho V. So mass is rho. Let's write that down. It's a Greek letter. So mass is density times volume, mass in kilograms or grams. So kilograms or grams. Volumes, cubic meters or centimeters cubed. And density is therefore in kilograms per cubic meter or grams per centimeters cubed. So we're going to the equation. So if you've got mass is density times volume, if you want to find density, we just need to get rid of a times volume. So we need to do the opposite, which is divide. So that would mean mass divided by volume. So density is mass divided by volume. And if you wanted to get volume, we need to get rid of a times density. So obviously to get rid of a times density, we do the opposite, which is divide. So volume would be mass divided by density. You can get those down if you're not sure. And then let's do some questions. So if you want to pause and have a go at these, and then I'll take you through the answers. So the first one, calculate the density of a block which has a mass of 400 grams and a volume of 50 cubic centimeters. So relatively straightforward. The density is mass over volume by definition, and the mass is 400 grams, and the volume is 50 centimeters cubed. So if you put that in your calculator, or just divide it, because you can do maths. Obviously, 400 divided by 50 is relatively straightforward. It's 8 grams per centimetre cubed. Okay, let's look at the next one. So calculate the volume of a block, which has a mass of 500 kilograms and 1600 kilograms per cubic metre. And you might be wondering, if we use those values, what volume will we get? It'll be in cubic metres, as you can see there. Okay. Anyway, so mass is density times volume. So volume is simply going to be the mass divided by the density, because they're multiplied together. We need to divide by density on the other side. So mass divided by density. So that will be 500 kilograms divided by 1,600 kilograms per meter cubed. And that gives us 0.31 cubic meters. You might have written 0.12 or 0.13 or 0.125. Which is fine, it's still the correct answer. Well, two significant figures is fine. So let's look at this one. So a liquid in a beaker has a volume of 0.000851 cubic meters and a density of 1,170 kilograms per meter cube. Calculate the mass of the liquid. So that's straightforward. Mass is density times volume. So the density is 1,170 times the volume 0.000851. And that gives us 0.995, or just 1 kilogram. Hopefully you found those okay. Let's ramp the difficulty up a little bit then. So this one should be relatively straightforward. It's a little bit trickier, but nothing too drastic. So you have to pause and have a go at this, and then I'll take you through the answers. So a cuboid has dimensions of 30 centimeters, 50 and 40. Now what you need to do to get the density is either convert the 15 kilograms into grams, or convert the distances into meters. So I'll do both just for this one example. So let's leave them in centimeters, and we'll convert this into grams, which I wouldn't have done actually. But that 15 kilograms is 15,000 grams, because obviously there's 1,000 grams in a kilogram. And then the density is just the mass divided by volume. So the mass is 15,000 grams divided by, and then we've got these dimensions, 30 by 50 by 40, so we need to multiply them together. So 30 by 50 times 40, should have done that in maths already, equals, so it's 15,000 divided by 60,000, and the density will be 0.25 grams per centimetre cubed. Then what I'm going to do is do it in kilograms and meters cubed. So density is mass divided by volume. So the mass this time is 15 kilograms divided by, now what I'm going to do is turn them all into meters by dividing by 100. So it's 0.3 times 0.5 times 0.4. So let's pop that in. So 0.3 times 0.5 times 0.4. And if you calculate that, we get a density that's equal to 250 kilograms per meter cubed. Hopefully that went okay. Alright, let's do something a bit more challenging. Right, okay, so if you want to pause and have a go at this one. So gold has a density of 19,300 kilograms per cubic meter. Calculate the weight of a gold ingot of dimensions, length 272 millimeters, width of 94.5 millimeters, and a depth of 51.5 millimeters. Right, so what I'm going to do is divide all of these by 1,000 to get them into meters. And then what we can do is figure out the volume. Okay, so the first one is 0.272 meters multiplied by 0.0945, and then the 51.5 millimeters we need to divide by 1,000 gives us 0.0515. Obviously we're dividing by 1,000 because there's 1,000 millimeters in a meter. So that gives us a volume of, if we multiply them together, so we've got 0.00132, choose 38, choose 5 significant figures, cubic meters. If you use less or more, it's okay. Really, if you've got a scientific calculator, you can just use the full number. So, and then mass is density times volume. So the density of gold is 19,300 multiplied by the volume that we've got, which is the 0.0013, so on. I'm going to use the full number in my calculator, so I'm just going to multiply what I've just calculated by 19,300, which gives us a mass that is equal to 25.5 kilograms. There are actually gold bars this size. I got these dimensions, you know, from the Bank of England or US equivalent. Anyway, that's the mass, but it's actually asks, if you got that, well done, you've done really good, but it asks for the weight. And if you've done this, you should have done it. If you haven't, then this might be a surprise. I've got a video on it, Forces Lesson 4, I believe, weight is mass times gravity. So weight is the 25.5. I'm going to use the full number, the 25.5484908. All right, 25.5 multiplied by the gravitational field strength on Earth, which is 9.8 newtons per kilogram. So if what's in your calculator, if you just times that by 9.8, that will give you a weight of 250 newtons. If you got that right, really well done. And then the last but not least is the mad extension question. So if you get this next one wrong, don't worry, it's pretty tricky. So here's the question. Want to have a go at it? I'm going to give you a help tip in a couple of seconds. So if you don't want the help tip, press pause. So what you will need to do this question is the volume of a sphere, which is volume is equal to 4/3 pi times the radius cubed, or 4/3 pi r cubed. And what I'll do now is take you through this question, show you how to do it. So what we need to do is to use the mass's density times volume to find the volume. So volume is mass divided by density. So volume is mass divided by the density. So we'll do that first. So the mass is 6 times 10 to the power of 24. So you should do that in standard form. So you literally just press 6, and then you should have a button at the bottom of the calculator. Times 10x. So basically, to put that number in your calculator, if you're not sure, you would press the button 6. Then x10x. x10x. Let me just do that again. (24). So 6 times 10 to the power of 24. Divided by the density, 5,464 kilograms per cubic meter. That gives a volume of 1.098 times 10 to the power of 21 cubic meters. Okay. So I'm going to make some room actually. Right, so what we need to do is take the equation v equals 4/3 pi r cubed, and we need to rearrange to make r the subject. So this is basically a maths lesson now. So we need to get rid of the divide by 3, so to do that we times by 3, and then we need to get rid of the times 4, so we divide by 4. So we actually end up with times 3v divided by 4 equals pi r cubed. Then we need to get rid of the times pi, so the opposite of timesing by pi is dividing by pi. So that would be 3v divided by 4 pi. So I'm just going to move that over. So get rid of times pi. Divide by pi. And you can put that in your calculator. 3 times the volume divided by 4 pi. And that is r cubed. Then you just need to do the cube root. If you want to write that out in full, I imagine we can do the cube root of. So that looks like that. 3 times the volume. So 3 times 1.098 times 10 to the 21. Divided by 4 pi. Put that on your calculator. The cube root button, by the way, on a Casio is shift and then the normal square root button. So you can see like in yellow writing it says 3 root. So that'd be the cube root of, and then just tap it into your calculator 3 to, you know, as you would normally. And that should give you a pretty long number, so a bit more calculator skills. There should be a button on the calculator called ENG. And it stands for engineering, and it will put your answer in an engineering prefix. And if you press that, if you've done it right, you should get a radius that is equal to 6.39 or 6.4 times 10 to the power of 6 meters. So what ENG will do, it'll put it to a kilo, mega, giga, milli, micro, those type of things. So if you're writing that as an engineering prefix, it'd be 6.4 times 10 to the 6 is million, so megameters. And that's it. Hopefully you can follow that as best you can. If you got it right, excellent, amazingly well done. Bit of a long video, so I'm going to stop it now, but thanks for watching, and I'll speak to you soon.